Hello everyone, this is Kalpana here. In this video we are going to see a problem from partial differential equations. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants a, b from z equal to a times x plus y plus b. So we are given a relation z equal to a times x plus y plus b. Consider it as equation 1. See, it has arbitrary constants a and b. So now by eliminating arbitrary constants, we need to form a partial differential equation from this relation. Okay. So now what we'll do is we'll just partially differentiate one with respect to x and one with respect to y. Okay. First we will begin with respect to x. Okay. Partially differentiating one with respect to x. So here we'll partially differentiate both sides of the equation with respect to x. So we'll get dou z by dou x equal to, here a is treated as constant, right? So we'll write it as a into partial derivative of x plus y plus b is constant, right? Okay, we can write like this, or you can just write like this. Okay, since dou z by dou x equal to p from the notation, useful notation, so these are the notations we need to remember while coming to partial differential equations. Okay, fine. Now we'll write this as constant into partial derivative of x plus y plus partial derivative of a constant with respect to x is 0. From this you'll get p equal to a into partial derivative of x with respect to x plus partial derivative of a constant with respect to x. Okay, which gives us p equal to a into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0. From this you will get p equal to a into 1, which gives us p equal to a. Consider it as equation 2. Okay, here I'm making number of steps. See, you can just skip these two. Well, let's see that later. Fine, now let's partially differentiate 1 with respect to y. Okay, partially differentiating 1 with respect to y. Okay, dou by dou y of the LHS part equal to dou by dou y of the RHS part. This gives us dou z by dou y equal to dou by dou y of the first term, a times x plus y plus partial derivative of the second term. This gives us, we have a notation dou z by dou y equal to q, so just replace it with q. You'll get q equal to constant a into partial derivative of x plus y, because here in this we have y, so you'll take x plus y plus partial derivative of a constant b with respect to y is 0. Now we can write this as a into partial derivative of x with respect to y plus partial derivative of y with respect to y. Okay, we can write this as q equal to a into partial derivative of x with respect to y is 0, because x is a constant. Since we are partially differentiating terms with respect to y, so we'll treat x as constant. Okay, plus partial derivative of y with respect to y is 1. This gives us q equal to a into 0 plus 1 is 1. From this we'll get q equal to a. Consider as equation 3. Now Observe 1, 2 and 3. Okay, let's assume that we are replacing or we'll just put 2 and 3 in equation 1. Okay, you have P equal to A, Q equal to A. So you can replace A by P, either P or either Q. Okay, we can replace A by either P or either Q, right? Then if you replace, suppose if you replace A by P, then you'll get P times Z equal to P times X plus Y. Still B remains, right? The constants will not get eliminated by replacing 2 and 3 in 1. Okay, so what we'll do is, from 2 and 3 we get, what we'll get? P equal to A, Q equal to A, right? P equal to A, again we have A equal to, which is Q. From this we will get P equal to Q. Therefore P equal to Q, which does not involve any arbitrary constants, right? Therefore P equal to Q is the required partial differential equation. Okay, by replacing or by substituting 2 and 3 in 1, the arbitrary constant B will remain the same and it won't get eliminated. So from 2 and 3 will bring the required partial differential equation, or will form the required partial differential equation, we can say, right? Fine. Now this completes the problem. Let's see how to reduce number of steps while partially differentiating one with respect to x and y. Okay, I'm doing the same problem one more time directly without involving number of steps. Without including number of steps. Okay, so let's see that. So we have equation 1, a relation which is in x, y, z, a, b equal to 0 form. Okay, fine. Now partially differentiating 1 with respect to x, dou z by dou x equal to a into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 plus partial derivative of a constant b with respect to with respect to x is 0. So you'll get, just replace it by the notation P, since dou z by dou x equal to P equal to a times 1 plus 0 is 1. From this we'll get P equal to a, which is considered as equation 2, right? Now partially differentiating 1 with respect to y. Okay, we'll get dou z by dou y equal to a into partial derivative of x, that is a constant, since we are partially differentiating with respect to y, right? So we'll treat x as constant here. So partial derivative of a constant with respect to y is 0 plus partial derivative of y with respect to y is 1 plus partial derivative of a constant with respect to y is 0, right? Now replace it by a notation q, since dou z by dou y equal to q, right? Fine. Now this gives us a into 0 plus 1 is 1. From this we'll get q equal to a, which we have considered as equation 3, right? Now we need to observe 1, 2 and 3. By substituting 2 and 3 in 1, the constant b remains the same. Here our main motto is to eliminate constants, arbitrary constants a, b from the relation z equal to a times x plus y plus b, which gives a partial differential equation, the required partial differential equation, right? Since by replacing 2 and 3, by substituting 2 and 3 in 1, b remains the same, that is b won't get eliminated, so we won't substitute 2, 3 in 1. So what we'll do is, since p equal to a, q equal to a, by observing these two we can say that p equal to q, right, since it is both are equal to a. So we'll get p equal to q, right, from 2 and 3 p equal to q. So from this we'll get p equal to q. From this we can say that p equal to q is a required partial differential equation which does not involve any arbitrary constants, right? Fine. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.